I, I can't believe I'm saying this as like a half German to a bunch of Israelis, but you now get to relax a bit, right? Like after Sharon has been putting us through our paces, yeah, cracking the whip all afternoon long. So this is a 90-minute workshop, and so the pace is going to be just a little slower here. What we're going to be talking about is automation, or more precisely, orchestration in OpenStack. Before I get started, though, I'd like to have sort of a quick show of hands. For whom of you is this OpenStack Day basically your first foray into OpenStack? So people who would say that, well, I haven't really done a whole lot of work with OpenStack up to this point, and so I'm here to basically get my feet wet or get my hands dirty, whatever. Okay? So that's about a third. All right, fine. For the rest, I presume that you're already using OpenStack either in production or in some sort of an advanced POC or testing or something like that. Is there anyone in here who actually does have some experience with OpenStack orchestration or OpenStack Heat? If so, please raise your hands. Okay, that's just 3 people. That's great. So that means that the majority of you, I can teach you something, which is good. Just out of curiosity, though, anyone in here have experience with cloud orchestration in other cloud platforms? So for example, AWS CloudFormation or Google Cloud Platform Deployment Manager. Any experience with that? What is that? Like, is that AWS? What is that? Okay. How about VCO, VMware Cloud Orchestrator? Yes, a little bit. Okay. It's like everyone who raises their hand is like has this embarrassed smile of, yeah, I've been using this, but I hate it. Right? Is that kind of what you were trying to say? All right, fair enough. It's all good. Okay, good. All right, so we have a nice and interesting mix here. So what we're talking about really is we're talking about automation. We're talking about the automation, however, of virtual systems in OpenStack. So I'm really fundamentally not talking about automating the deployment of OpenStack itself. There's multiple ways of doing that, but for the purposes of this talk, I'm assuming that we already have an OpenStack cloud available to us. So I'm assuming that the problem of actually deploying OpenStack, that's solved for us. Okay? And now we talk about how we can actually automate virtual systems in OpenStack. So there's a bit of a prerequisite, of course, that you should know at least a little bit about OpenStack. You should be generally familiar with some of the basics of OpenStack, such as, you should know that Nova is the thing that manages our virtual machines. You should be aware that Neutron is the thing that manages virtual networking, and so on. And just so you know, all of the content that I'm showing here in the slides, you don't need to snap any pictures of those slides, is up on GitHub. You can go to github.com/fghaas. That's my personal GitHub repo. And then OpenStack Israel 2017 Heat. You will find all of the information that I'm using here in these slides, and the rendered slides are available there as well. Now, of course, it wouldn't be a workshop if I didn't have actually some hands-on work for you to do. And so what you will need is you're going to need an OpenStack cloud and OpenStack credentials to access that cloud. If you didn't bring your OpenStack cloud with you, fear not, because I can still help you out. Let me just wanted to move this out of the way, because otherwise we get the kind of feedback that I don't want. And oh, by the way, I'm in Israel, so I don't need to ask anyone to ask questions, because you're going to shout them out anyway, right? Which is perfectly fine by me, and that's all good. So please, by all means, don't change your ways, right? Because that's what you're here for, and this is meant to be an interactive workshop. Okay, so you're going to need OpenStack credentials, and if you don't have any, then I have some for you. And I will show you briefly how to get to those. Now this is going to be slightly awkward here, because I'm going to have to open up a new tab. Okay, and what I would like you to do is this. So, by the way, this is purely voluntary. If you want to follow along with what I'm doing here, you are welcome to do so. If you don't, if you just want to listen to what I'm talking about, that is perfectly fine as well. Like I said, all the material is up on GitHub. It's very easy to duplicate what I'm talking about in your own environment, in your own OpenStack cloud. For example, if you're here on the public Wi-Fi and you don't have access to your cloud, which I'm assuming is the case for some of our friends in uniform who are here today, then you can follow along here, or you can follow along offline on your own at any time. So, but what I'm going to give you is, so here's what I'm going to be using throughout. So that is, there we go. That's our training website. It's academy.hastexo.com. And there's a course on there. It's called Advanced OpenStack Orchestration at OpenStack Day Israel 2017. And what I would ask you to do is you should now, at this point, do this. You should go to, hang on a second, you should go to store.hastexo.com. That's our website. Relax, you're not going to buy anything there. I just need you to register there because that's how our authentication against the learning platform works. So that's store.hastexo.com. And if you go there, there's the resolution here of this projector is not the greatest. There's a login or register button at the top right there, okay? And once you log in or register there, then I can also give you access. I can also give you access to the other stuff. So let me pull this over here really quickly, and let me do something to that. So in the interim, if you want to follow along, go to store.hastexo.com. That's a site that's up here. There's a login or register, and you can go ahead and log into that. Okay, and I'm going to give you a couple of minutes to do that. And then when hopefully everyone has caught up with me on that, I'm going to tell you how to proceed. So you'll have about 2 or 3 minutes here to do this. Store.hastexo, that's HASTEXO.com. Okay, and you can, you can log in. You can basically select your own username and password, or you can also use your Gmail or Google Apps login, or whichever you'd like. Okay, and I'm gonna briefly walk you through how this works. So hang on. Okay, so like once you've done that, and you go back to academy.hastexo.com. So first you go to store.hastexo.com, then you go to academy.hastexo.com. Okay, and if you go there, and there's going to be this course here. It's called Advanced OpenStack Orchestration, OpenStack Day Israel 2017. And you can click on that, and then you can say Enroll. Okay, and when you click on the Enroll button, there is a sign in, and it says create an account using Hastexo or already have an account and sign in. So in that case, what I'm going to ask you to do is click on the create an account using Hastexo one, and then you are able, that automatically then creates an account on our Academy website as well. In my case, of course, I've already done that, right? So what I now need to do is, so hang on, what I do is this. So I basically, just walking you through this here, I go to store.hastexo.com. So I log in. I use my Google login for that purpose. There we go. So now I'm logged in here, and then I can do this. I can go back to Academy, do sign in. You would do create an account, sign in, Hastexo, like this. And then I authorize that OAuth login, and then I'm in, right? Then I'm enrolled in this course. Okay? Again, like I said, this is purely optional. If you want to do this right now, then please, by all means, go ahead. And if you don't feel like that, then you can just watch me, basically, as I go through this material. But you're totally going to be able to do exactly what I do on this platform. Because what happens if you go there, okay, is you have a bit of a course overview, and then we have a thing called course. Okay, and there's 3 labs in here. And then as you enter your first lab, what's going to happen is there's going to be a virtual environment, basically a virtual machine spun up just for you, that is going to pop up down here in this terminal, from whence you can then run OpenStack, heat, and so forth commands, right? And so this is only going to take a minute, and after that minute, hopefully we're going to see my terminal pop up here. At least it did pop up perfectly fine a few moments ago. What you can do is you can register, you can log in, you can go into that course, and you can then just go into sort of the first lab window, and that's going to fire up your stack in the background. That's going to take just a minute or two, and once that is complete, then we can carry on. In the interim, I'm going to talk a little bit about sort of basics of heat orchestration and the like. And so this stack is already up. Let's see. There we go. That looks better. Right? And then so that in the end, that drops you into a terminal like this. And that is a terminal that you can actually interact with, right? Okay, so it's going to take about 3 to 4 minutes for each of you to fire that up. It might take a little longer because we've got like multiple learners accessing this at the same time, but this is generally how it's going to look. And so in a few minutes, when I continue here with my first actual hands-on, and of course I'm going to have something better to present to you than just this thing, then we can proceed. Okay? Did I see a hand up there earlier? Did you have a question? No question. Okay, cool. What is that? Yeah, sure. That's fine. It can take. So I'll go over like what this thing does in detail when I'm done with the talk, because as it happens, a lot of what's happening here is actually directly related to what I'm talking about. Okay. So in the interim, I'm being fooled here by my mouse pointer, which is very weird. Huh. Okay. That's funny. There we go. All right. Let's close that. Come on. There we go. There we go. And here, we're back. Okay, so in order to do what I'm talking about, like I said, you'll need OpenStack credentials, you need an OpenStack cloud. I just gave you those, and we'll come back to that in a little bit. All right, so what are we talking about in particular here? We're talking about heat, right? Now, HEAT in this case is not an acronym. If it is an acronym, then it stands for High Explosive Anti-Tank, and you don't want that coming your way if you're a tank commander. Here in this case, it's definitely not an acronym. Sometimes people write HEAT in all caps. Here it's just in all caps because all of my headings are in all caps. HEAT is called HEAT because heat is what makes clouds rise. Okay, so that's what it's called, or why it's called that. Now, as I mentioned before, Heat is not without precedent in other cloud environments. So AWS CloudFormation has been around for quite a while. Google has a similar offering that is called Google Cloud Platform Deployment Manager. In OpenStack, it's called officially the OpenStack Orchestration Service, or OpenStack Heat, because that's sort of the code name of the project. Now, what Heat allows us to do is we can describe arbitrarily complex virtual environments in OpenStack, just like CloudFormation does, just like GCP Deployment Manager does, and we can then manage them as a whole. We can manage them as a coherent unit. And this can be, like I said, arbitrarily complex. We could be firing up 50 different servers in 3 different networks that are connected with 2 routers, and we can have like all sets of firewall rules that are associated with that, for example, for a backend zone and for a DMZ and that sort of thing. So it can really be arbitrarily complex, and in general, or the general assumption is that if there's an OpenStack resource that you can fire up with, say, for example, a command line utility or a command line interface call, then you can also orchestrate it with Heat. In doing so, it uses a declarative language. That language is called HOT, the Heat Orchestration Template Language. It's YAML. So for those of you who have dealt with AWS CloudFormation before, you'll know that the AWS stack template is something that you write in JSON. In Heat, that is YAML. That's just basically just an arbitrary choice, more or less. I tend to prefer YAML over JSON, so I like that choice. The bottom line is it's a text-based format that's not exactly hard to read, not exactly hard to write, relatively descriptive, relatively self-explanatory. It's a generally good choice. In a Heat template, we can define the entirety of a stack, and basically the entirety of an arbitrarily complex virtual environment, which is a cool thing. Now, what is it that we can actually do with Heat? Well, there's a number of things. As I said, the general assumption is that if you can run it in OpenStack, then you can also orchestrate it with Heat. So let's start simple. One of the things that just about everyone who's running OpenStack or any kind of private or public cloud environment for that matter is going to want to do is fire up virtual machines, right? And of course, in OpenStack Nova, there's several ways of doing that. You can use the OpenStack dashboard, Horizon. You can use the Nova command line interface. You can use the unified OpenStack command line interface. You could use the OpenStack Nova REST API directly. You could be writing your application that interacts directly with the Nova API. And in Heat, you simply define a resource in a template. Now, resources they're generally objects that we define in our stack, and they can be just about anything. They can be a server, they can be a virtual network, they can be a virtual block device, and so forth. Resources all are identified by a name, and resources all have a type. And the type definition is kind of namespaced, and what we're using for firing up Nova guests and Nova virtual machines is simply called OS Nova Server. So the OS Nova Server type resource configures Nova guests in our Heat stack. So here's a snippet, actually a working snippet from a Heat template definition. In a Heat template definition, like I said, this is YAML, so this is basically a list of YAML dictionaries that we have in our template. And there's a dictionary that's named resources. Now that resources dictionary has multiple entries. They all need to be identified by name. In our case here, that name is mybox. And they are of a specific type, in this case OS Nova Server, and all resources that we define have 0 or more properties, so basically configurable knobs that we can tweak for these individual machines. So for example, what I could be doing is I could fire up a virtual machine that gets a host name of mybox that uses this specific image name, Ubuntu 16.04 Xenial Zeros, which happens to be an image that is just available on the cloud provider. By the way, did you ever like think about why Ubuntu 16.04 Xenial Xeris uses the English term and not the German term for the same thing? It's because the German term for a Xenial Xeris is gastfreundliches Borstenhörnchen, and I'm pretty sure that like no one who doesn't speak German natively could pronounce that. So we define this thing. We say we want to run it on Ubuntu Xenial. We want to define a specific flavor. We want to inject a specific SSH key into this thing, and now we could take this definition and fire up the stack. And the way that we do that is, again, there's multiple ways of doing this. One of them is just to use the OpenStack CLI tool. We do OpenStack stack create -t, that stands for template. That is the template file that we specify. And then the stack has to get a name. And that's it, right? There's not much more to it. But of course, as it is, up to this point, I've not shown you anything more interesting than what you can just do with a Nova boot or an OpenStack server create call, right? So as it is, this thing is not very flexible at all, so let's change that a little bit. Let's change that up a little bit. Let's add some parameters to do that. So parameters, for those of you who are familiar with, say, for example, CloudFormation, nothing new to you here. This is simply concept that Heat copied straight up from AWS CloudFormation. That is just another dictionary in the template. It's called parameters, and they can have any name. They have multiple types. We have, for example, we have a string type, an integer type, a Boolean type, a comma delimited list, and we can also pass raw JSON if we want to do that. We can also provide a description that's only used for things like Horizon, for example, to provide UI hints from Horizon. And then there are some parameters that we can designate as optional. So if on a parameter we set a default, then that means as the stack is being fired up, we don't necessarily need to set those parameters. We can just instead use the defaults, right? That's a relatively common concept. Now, how do we use these? How do we use these parameters? There's intrinsic functions for that purpose. So the Heat orchestration template language doesn't only have these dictionaries for resources and parameters, and there's a few others that we're going to get to in a second. But we also have this concept of built-in or intrinsic functions, and one that you're going to be using very, very heavily is an intrinsic function named getParam. So if instead of hard-coding the image name or hard-coding the flavor or hard-coding the key name, we can simply refer to these parameters, right? So instead of just using the hard-coded value, we write getParam : followed by the parameter name, and off we go. And then we can set these parameters from the outside. So for example, we could do an OpenStack stack create, again, -t for referring to the template, and then --parameter for setting some of these parameters. And of course, I don't need to set all the parameters all the time. I just need to set those for which no defaults exist. And then again, the stack gets a name. All right, so we've added a little bit of configurability or parameterizability, if that's a word, I'm not sure, to our stack. But still, we haven't done anything that we can't also do in, say, a shell script that uses these as just, command line arguments or something like that. So we're not really, we haven't really done a whole lot of anything worthy of the term orchestration yet. So one of the things that a VM always needs is network connectivity, right? We always want to be able to not only fire up a VM, not only just have it up and have it crunch some data perhaps that it gets from a block device or whatever and then shut down. Frequently we want to run some services that need to be accessible from the outside, that need some sort of network connectivity. And of course, again, we have resources in Heat, in the Heat orchestration template language that we can use here, that we can define here. These are called OS Neutron Net and OS Neutron Subnet. For those of you not quite familiar with OpenStack and or Neutron, a Neutron network is a relatively abstract object in OpenStack Neutron terms. A subnet is where all the action actually happens, as you will see in the following example, which is we just define a network. The network basically has just a name and a type, and that's it. And then everything that's actually interesting is defined on the subnet level. So we can define whether a subnet is IPv4 or IPv6. We can define what is the DHCP allocation range that we want to specify. We can set things like DNS name servers, and so on and so forth. So the subnet is really sort of where the action happens. But if you're eagle-eyed, then you're going to see that in this snippet that I put up here, there is yet another intrinsic function that is in play. I previously introduced you to getParam. Here's another one that you can see here for the network definition, or a network reference actually. And so that thing is called, or that function is called getResource, another intrinsic function. But there's something that's actually really cool about it, which is getResource is not only there for providing or defining a cross-reference between two individual resources, but it also creates an automatic dependency in the process. So heat templates, heat orchestration template language templates, are not procedural. You don't have to say, okay, first create this, and then create that, and then create that, but they are declarative. You're simply saying, okay, I want this resource, and that resource, and that resource, and they're connected in such and such way. And then the heat engine is the thing that actually figures out, okay, we have a dependency chain here. So we have one, so in this example here, right, we have one independent resource, that's the network, and then we have a dependent resource, that is the subnet. So the network has to be created first, and then we can create the subnet, and we can plug that in. So I could have flipped this definition on its head, right? I could have defined the subnet first, and then the network, and heat would still do the right thing in the right order. So an important thing to take away here is we do get sort of this automatic dependency tracking in heat. And that is a ridiculously useful feature, as you will see in a bit. Okay, there's perhaps various other things that we want to do to heat or for heat, or rather for our virtual environment that runs in heat. So for example, we might want to allow our virtual machines to connect outside their own subnet, right? In order to do that, we either need to plug them into an existing virtual router, or maybe we're firing up a virtual router, right? Maybe we're just creating a new virtual router, an upstream gateway for it, and so on. And an example for that is something that you can see here, right? So those are just additional resources, a router gateway, and so forth. And in this case here, in this example, we are using a parameter to define, okay, what is the external network that we actually want to plug this thing into, right? Because recall, in OpenStack, for several releases, we've now had the ability to have multiple external networks, multiple networks that you can take floating IPs from it, and so forth. Okay, I'm going to skim over the rest here a little bit because you're going to see this actually live and in full color in a second. We can define certain settings for Neutron ports, so for individual network interfaces. We can, among other things, define security group rules. So that means, for example, you might want to create your heat stack such that all of your Linux virtual machines in that thing are automatically accessible via SSH and are pingable. And you might want to also assign floating IP addresses as you fire up your stack. That's another thing that's very simple and easy to do. Now, you do have to understand, however, that as with everything in OpenStack, creating a heat stack is an asynchronous process. So you say OpenStack stack create, that call returns immediately, and then you can poll that stack a few times, and at some point it goes into the state create complete, and then you can actually use the full stack. Now, that what that implies, of course, is in the case of floating IPs, you might be firing up a stack, the stack takes 5 minutes to create, and about halfway through, Neutron allocates a floating IP for you. How the hell do you know what that floating IP is? Well, again, a concept that was directly inherited or inspired by CloudFormation is the concept of outputs. And outputs allow us to just return stack values or attributes of certain resources in the stack so we can then read them out. And we define them in yet another dictionary called outputs. So for example, in this case, we're creating an output named public IP, and we're getting the floating IP address out of there. And then we can simply retrieve that with OpenStack stack output show. All right. So now we're actually going to get cracking. Okay? So all right. So, if you're going back to your lab environment, then that may have suspended in the interim. But you can go straight back to it, and it should come right back up. And hang on a sec. There we go. That works. Perfect. I just don't know why we just dropped out of the... Oh, come on. Where's that thing? Here we go. That's it. Okay. All right. So, can I have a show of hands, please? Who actually fired up a terminal for themselves? Okay. So there's a few people in there. All right. So you can drop right into this terminal there, and this is what it would look like. Okay. So you find a little bit of information in there. Most importantly, there is an OpenStack RC file in here. Which allows you to connect to a public OpenStack environment that was generously made available from our partners at CityCloud. If you or your company is looking for a public OpenStack cloud that is not more expensive than AWS and has locations in, well, they have 4 in Europe by now, 2 in the US, 1 in Japan, and 1 in the UAE. Then go take a look. So, of course, I said what we need here is credentials. And we're just going to source this OpenStack RC file here. And then there's one other thing that you're going to have to do, which is you're going to have to export your OS password. And I have temporarily reset that thing to OpenStack 2017, so the same password that we also have on the conference Wi-Fi, right? So you want to source that OpenStack RC file, and you want to export your OS password to OpenStack 2017. And once you have done that, you should be able to do an OpenStack token issue. And that basically is just a connectivity check and a check whether you are properly able to authenticate to the stack. To the public cloud API. Okay? So again, that is source your OpenStack RC, export your OS password to OpenStack 2017, and then quickly do an OpenStack token issue. If that returns without error, then you are able to properly authenticate against that public cloud environment. Okay? And then there's one other thing that I would like you to do, which is you're going to see in your directory here, you're going to see a file that is named stack name. Okay, and what I would like you to do is I would like you to basically you can go ahead and cat that, right? It doesn't have a new line, unfortunately. Sorry about that. Again, what I would like you to do is just do this, right? Do an export stack name like this. Okay, and then there's probably a million ways to do this in Bash, right? But you can just do that. And then you should be able to do an echo of stack name. And it should contain that. Well, it should contain something else for you, but this is what it has for me. and so you should have like a stack name in there. What is that? The stack. I prefer that you not change that stack name, and I'll tell you why in a second. Okay? All right, so now in just above that terminal, you have some lab instructions. So all of what I'm about to tell you is also written in there. So feel free to refer back to that in case you get stuck. We're going to look at one YAML template that is already there. It's a simple YAML template, a simple hot template, which is going to give us a very simple stack, and then we can build upon that, okay? So we're going to use an editor. I'm going to use Vim here to look at this thing called simple.yaml, okay? And as you can see, this is a really simple thing. We've got a handful of parameters. We define an image, for example, an image parameter, a key name, public network, and then we have a handful of resources. So we've got our, so hang on, let's see, set bg equals light. Does that make things better? Not really, right? Okay, sorry about the color scheme here. I realize that the cyan is probably not really easy to read. So we define a box, right? We define an instance, a Nova instance. We do a little bit of magic with its port. So, for example, we plug it into a specific security group. Here in this case, you see we define the port first, and then the network, and then the subnet. That doesn't matter at all. It will do the right thing. It would just first create the network, then create the subnet, then create the security groups, and then the ports to plug that in, and then we'll plug that port into our VM. Okay. And then we also create a virtual router and a floating IP and so forth for this thing. Okay, so a very simple stack. All it does, it fires up a single virtual machine, but it also gives that virtual machine full network connectivity, and it makes it accessible from the outside, including a ping and an SSH. All right, so what we're going to do now is we're going to fire this thing up. Okay, and the way that we do this is this. Okay, we're going to do, whoops. Hang on. There we go. Okay, so okay, let's keep it like super simple for right now. Okay, let's do this. All right, we're not setting any parameters at all whatsoever. We're just going to do OpenStack stack create -t simple YAML, and then we're going to create stack name. Now the reason I'm asking you to use the stack name that I predefined is you're all going into the same OpenStack project, and I don't want name clashes to happen, right? So I gave every one of your environments a specific stack name there. Okay, and then we can simply fire this off. Okay, and this kicks off the deployment process. And as you can see, what we get back is immediately the stack goes into this create in progress state. We do get an immediate HTTP 200, so the call immediately returns as such. And the stack then goes to the state create in progress. Now, as we're going to see, there are multiple of these defined states. We go from create in progress, and then there is a create complete at some point. We can also update stacks, we can snapshot stacks, we can suspend stacks, and so on. So there's a bunch of things really that we can do. And what we can also do is we can monitor the progress of the stack. We can do that in one of two ways. We can either do an OpenStack stack show stack name, like this, okay? And we will get some pretty long output there. It's a lot of stuff that's being created here. But I can also do an OpenStack stack list, which will show me all of the stacks in this tenant, in this environment. And as I can see here, there are already a handful of stacks that came up. Apparently someone misunderstood the backticks here with the cat command. That's fine, as long as we just have one cat, that's okay. After all of OpenStack Swift, for example, was originally built for hosting pictures of cats, right? So this is all good. But as I can see, a bunch of you already have these stacks fired up and in the create complete state. Now, what we did as part of this was we created a floating IP, right? And so that floating IP has now been assigned to the stack, and I'm going to do a stack output show followed by my stack name here, stack name, there we go, and I'm going to ask for my public IP output, okay? So there we go, and I've found out this way that my, my stack has been assigned the IP 89.46.85.72, right? Okay, so let's take a look, because that thing should now be pingable, right? So that is 89.46.85.72, and as it happens, all right, there's actually something alive there, right? So there's a VM that not only is responding to my pings, but it's also actually allowed from the outside to ping this thing via its floating IP address. Now I could also go ahead and say, well, all right, so I wanna ping this thing, right? So I'm able to ping this thing, so I want to connect to it, and so I should also be able to SSH into this thing, right? So hang on a second, let me just clear the screen here so you can see this a little better. Okay, so I should also be able to SSH into this thing, and as I can see, there's actually an SSH server responding here, because otherwise I wouldn't be seeing this. And if I say, okay, yeah, I want to continue to this thing, it of course is telling me, well, you've actually not deployed a private key to this, right? Okay, so, all right, I forgot something about my stack, right? So there's a couple of things that I could do here now. I could, for example, I could just throw the stack away and do it afresh. But the first thing that I, of course, need to provide is I actually need to provide a key pair, right? So as it happens, we already have a key, okay, well, that's going to be a little more difficult for me here than it is for you. Because what you can do is you can just do this. You can just go into .ssh, okay, and you could just do a cat authorized keys to id rsa.pub, like this. Like for you, you can do that straight away, okay? For me, I'm going to have to do something else because I've also injected another key into this. So I'm going to do a grep-v Florian authorized keys, and then put that out, and then I just have my id rsa.pub. There we go. Okay, so that's the generated by Nova key that's in there. All right. And now what I can do is I can do an OpenStack. Hang on, flush that again. So let's do an OpenStack. Well, let's give you the whole shebang. OpenStack. There we go. Okay, so there's a bunch of things that we can do there. A bunch of options that we can set, etc., etc., etc. Yada yada yada. Okay, and what we are looking into is come on here. Okay, so that's key pair create, right? Okay. Wait. So this is slow. This terminal is slower than mine here. So just a second. Okay, key pair create. All right, that's what we want to do. And here's how we do that. OpenStack key pair create. And what do we want to do there? we want to do this. We want to do an, wait, hang on, just a sec. Okay. And so this is how this works. OpenStack key, come on, key pair create. Okay, and then we're going to set public key, and then that's going to be our .ssh id rsa.pub. Okay, and again, please name the key pair just like your stack name. Okay, so like this. There we go. So that means we have now uploaded this key into our environment there. Okay, and now what I'm going to do is I'm just going to update my stack to inject that key pair. All right. So this is how we do that. So we did OpenStack stack create. Okay, -t. Simply YAML stack name, okay? And now what we're going to do is we're going to do OpenStack stack update. All right, OpenStack stack update. We're going to use --existing, so stack existing. Let me type that right, okay? OpenStack stack update, T template file. --existing means preserve all the existing defined parameters. Okay, and now we're going to add a parameter to this, which is parameter key name equals, and we named the key exactly the same as our stack, so we're going to do parameter key name equals stack name, and then of course the name of the stack itself, okay, like that. So what we're doing here is we're updating an existing stack. Now, Heat is smart enough to figure out what update means for specific types of resources, right? For some types of resources, such as in this case, a server, where we're just, sort of changing that configuration, or if we changed user config, etc., we'll just rebuild the server. In other cases, it will just replace in place. Okay, so we're going to do OpenStack stack update of this thing. All right, and I'm going to leave this as it is for a second if you want to copy down that, that command. As it says here, stack update started. Okay, and in the interim, what I'm going to do is I'm going to do an SSH agent bash. I'm just going to start an SSH agent here. Actually, hang on, let's do this. Let's do history /w first, and then let's do an SSH agent bash. Okay. And let's get the output again. Output show, okay. So there's my public IP. I don't even know whether that's changed to what I did earlier, so let's see. 72, all right, that's fine. Okay, and so this is what I want to connect to. And, oh, yeah, and then I also want to do an SSH add. So my identity is actually being added to the agent, right? All right, so let's see. And as I can see here now, the whole VM has been replaced. That's why I have a new host key. So we're going to replace that. I basically drop it from our list here. So there we go. And let's try this again. Boom, I'm in, right? There's my VM, and I'm basically ready to go here. Okay, fine. We have a VM here. There's a few things that we can still do to this, right? So for right now, very simple VM. We just fired up an Ubuntu VM, but you know, it's purely just the Ubuntu cloud image. There is nothing else to it. All right, and occasionally that sort of thing can get kind of boring, right? So we might want to do somewhat more interesting things. So next up, integrating Heat with Cloud Init. Now, Cloud Init is exceedingly useful. If you haven't been using Cloud Init up to this point, you've been making a big mistake. So you may or may not be familiar with the concept of Nova user data. Okay, and Nova user data is a means of injecting some configuration information on VM boot up and making that available to the VM as it starts up. And then there is this process that runs in the VM's image called Cloud Init that parses this information and then does interesting things with it. So, for example, if we want to do this in the Nova boot command or OpenStack server create command, we typically just set user data and then refer to some text file or whatever. And frequently what people put into user data is something like this. So user data can be any executable that can be used to interpret this. So if it starts with hash bang, it doesn't matter whether it's a shell or Perl or Python, whatever it is, as long as there is an interpreter for it in the VM image, you can use that. And then frequently what people do is they write a shell script where they do some sort of initialization and so on, and then, you know, assuming that completes successfully, then we're happy. Who in here has done this before? Who in here has like written a shell script and injected it into user data for Nova? Yes, you have? Okay, please stop doing that. It's a really bad idea. I mean, because for the simple reason that you can do much better than that. So if you're doing something like that, then chances are that you're going to be reinventing a lot of wheels, because what you typically are going to want to do on first boot up is relatively generic, relatively mundane configuration tasks, such as changing the mount point of a specific device, or rolling out some files on a VM, or injecting a specific user. Now, of course, you could write all of that in shell or in Python or in Perl or whatever, but you can do it in a much simpler fashion, and that is with cloud config. Now, cloud config is a syntax that enables us to bootstrap a newly booted VM, and just like Heat orchestration templates, the cloud config configuration language is 100% YAML. If you ask me, cloud config happens to be OpenStack's, actually not just OpenStack's, but generally Cloud Guest's most underrated feature. You can use Cloud Init in OpenStack, you can use it in AWS, EC2, you can use it in CloudStack, you can use it in VMware, you can use it like all over the place, and there's so much cool stuff that you can do with it, and so few people actually use it. So please, by all means, throw away your shell scripts, or at least look at what you can do with cloud config instead. And we can do a bunch of things with cloud config. For example, one of the things that are relatively complex and complicated to do when you code them in a shell script are things like, all right, what I really want to do is when I bring up a VM for the first time, I want to apply all of the patches that are available for that thing from the distro vendor, okay? And if you write that in shell, then you're either maintaining a different script for every distro that you support, or you do something like, are we running on Red Hat? In which case, run yum update. Or are we running on SUSE? In which case, run zipper ref and then zipper up. Or are we running on Debian or Ubuntu? In which case, let's run apt-get update and then apt-get upgrade. Or are we running on Fedora? In which case, we'll also use yum update, except if it's Fedora 23 or later, because then we have to invoke DNF. It's a mess, right? And it's much simpler to just set 2 Boolean variables in a text file. I can guarantee you that, okay? And in a cloud config configuration, you can simply say package update true, package upgrade true, and it will fetch the package cache, on first boot, and we'll just update or upgrade all of the packages that are installed there. And you're going to get a reasonably secure system right from the get-go, at least as far as like known vulnerabilities and patches and so forth are concerned. All you need to do in order to do that is to pass some user data that doesn't start with hashbang, but it starts with hash cloud config. The moment your user data that you pass starts with cloud config, it gets interpreted as a cloud config YAML configuration file. Again, breezing over the things are some of the things that you can do with this. You can create users and groups. So you, for example, define a specific user that you want to create. You might want to enable or disable SSH password authentication. Again, that's a single Boolean that you write. Maybe you want to roll out arbitrary files onto your environment. That's what you can do with write files. Looks like this, for example. You might want to roll out your etc hosts. Maybe all of your OpenStack tenants or projects run Puppet, a Puppet master. Maybe you want to run all of your VMs managed by Puppet. Simple to do. There's literally a configuration stanza that's named Puppet. All you tell it is, okay, where's your Puppet master? Then you can override the name that you want to use for this thing, and you can also roll out the appropriate CA certificate. So that means if you have auto-signing enabled, then your clients will only accept this specific CA certificate and will not try to log in or to register with anything else, which is generally cool. You can do that with Chef if you want to, and then you can do a bunch of other, like for example, you can also configure a salt minion and other things. Or you might want to do something super simple. You might just want to install a couple of packages. You might want to like fire up your VM and you want it to install Emacs immediately or Git immediately or something like that. And if that's not enough for you, if you want to absolutely totally also run that one specific shell script that you wrote, you can do that as well. You can run arbitrary commands with two types of cloud config configuration entries. There's boot command, which means you can run this really early in the boot sequence, or run command, which means you can run it late in the boot sequence, all of which is pretty cool. But it wouldn't be quite as cool if we couldn't also manage this thing directly from heat, which is really, really slick, because now we have a resource type that's called OS heat cloud config, which means we can inject this configuration directly into our heat template, as in, okay, just fire up your VM and update and upgrade all of our packages. And we can also then use heat parameters to set these cloud config options. So for example, we could say something like this. We could say, okay, we want to define a parameter of a common delimited list type. And that is going to be some additional packages that we are about to install. And as it happens, that is exactly what we're going to be doing in the next lab here. Okay? And that is the using Cloud Init and OS Heat Cloud Config lab. If you just change to that lab, it will drop you right into the same stack and right into the same session. But we're going to do a few more interesting things with our template, okay? So this here was my deployed Ubuntu box that I previously spun up. And now there's another template in your directory here, and that is called the intermediate template, okay? Just intermediate.yaml. And there's only a couple of things that are new here, which is we've got an additional parameter. It's right here. It's called packages, just as I gave in the example a moment ago, right? There's a parameter named packages. It's a common delimited list, and it defines the packages that we want to install. And then we have this thing called myconfig, and that is one of those OS Heat Cloud Config type resources. And what we're doing there is we're just updating and upgrading. We're just updating our package list. We're not doing a full upgrade. And we are also firing up these packages or installing these packages. Okay? Just so you believe me, by the way. So let's go really quickly back into this Ubuntu box here. Okay, and so let's see. There we go. So I want to run Emacs. There's no Emacs here, okay? And I want to run Cause. and there's no cause here, right? So we have identified these two packages, which for some reason we want in all of our VMs, right? And rather than installing them manually after the VM has been up, we can automate that process, okay? So here's what we're going to do. All right. We're going to do an OpenStack stack update. Now, this may be a little surprising, but yes, it is perfectly possible to update a stack in place with a different template, right? So you can change your stacks as you evolve. You can make changes to your templates. You can add additional resources or something like that. You can totally take a stack and update it with a different template. That's absolutely possible. We're again going to use existing in order to preserve all of the existing parameters that we have. And we're also going to say parameter, packages. And we want to install Emacs NoX, and we want to install cause, for whatever reason, right? We like Emacs, and we like cause. Oh, and then we want to do that with the stack name here. Okay, boom, off we go. All right, and that's our stack update that is starting. Now again, this is, for those of you who sat in Adam's talk earlier, we're really talking about cattle. We're talking about VMs that are relatively, that are replaceable, dispensable, right? So, or expendable is the right word, I guess. And so again, what's happening here is we're throwing the VM away and we're getting a new VM, but that new VM is now going to have those packages installed, okay? And so let's do this. Okay, so hang on. We're going to do the SSH again. It's already up, but it's up again with as a new VM. So we're going to forget this one, and we're going to reconnect to it. And I have to do this a little quickly, because there's something specific that I want to show you here, which is, if I look at this thing here. Yeah, not grep, less, just less. There we go. Let's see. Ah, too bad. I was apparently too slow, and this is already up. There we go. So, all right. So my Emacs is already here. Okay. So that's installed. And there's my cause, which is also here. All right. But I was actually not quite quick enough. Wait, come on, you don't know cause? Oh, please. Now you do, right? Cause is awesome. Does anyone in here use Ansible? Yeah, okay, everyone loves Ansible, great. So Ansible has this feature that when cause is installed, it will use it by default for all its output. So if you do have cause installed, then you have to set a specific Ansible configuration option to disable it, because otherwise it would just spout everything through cause, which I always thought was quite amusing. Okay, but I was actually being a bit too slow earlier, because what I wanted to show you really was the fact that I was able to reconnect to this thing, and the stack had already reported a completed update, even while this was still running. Okay? Now in this case, we're only talking about installing a couple of packages, which is really, really quick. But you can imagine that you can, of course, use this to a degree of completely arbitrary complexity. There could be things that take 15 minutes to complete after the VM is up, right? And normally what you really want is you want to be told that this thing is complete only when it's actually finished, right? You really would like for Heat to tell you, all right, well, I'm done with the actual update here, but only when it is actually and really and absolutely done, right? Okay, so let's look at that. Let's see what we can do about that. So hang on. What the hell? No, come on. What's wrong here? Sorry, hang on a second. We're just weirdly skipping around here. Okay, I'm having an issue with the slides here, and I don't want to bore you with watching me fixing that, but I can simply walk you through that. Okay, hang on. Let's go. There we go. So what you would really want to do instead is you want this thing to tell you when it's really done. And does anyone know how to solve this problem in CloudFormation by any chance? AWS CloudFormation. How do we let part of the stack like wait for other parts of the stack or that sort of thing? Anyone ever heard of wait conditions? The AWS folks? Anyone ever use wait conditions? No? Okay, never mind. So that's what you can use in this instance, because there is an equivalent of that in Heat as well, and that is called OS Heat wait condition. And if you're following along with the labs, then by all means, please switch to the third lab. It's called OS Heat wait condition, using OS Heat wait condition. And now let me show you what that is about. And I'm simply going to show you directly in the template. And unfortunately, Adam is only here now, right? Because I made this whole idea of automating the installation of Emacs in our VMs. That's basically what I did for you. And then he's late. Too bad. Anyway, wait conditions. So the final template, the final modification of the template that you have, and I'm going to use VI just to piss Adam off here. Is called advanced.yaml, okay? And there's actually not that much change. There's just a little bit here, okay? And that's this. So this is called a wait condition. I'm just going to highlight that here, okay? This is called a wait condition, and it comes with a wait condition handle. A wait condition simply means, it tells Heat, okay, to wait for something. And specifically, it basically wants a number of reports that a certain thing is done. In this case, it only wants one report because the count is set to 1 here. And a wait condition is always linked with a wait condition handle, right? That's the handle property here. And again, recall, this is a dependency chain, so Heat is smart enough to figure out that we want the wait condition handle created first and then the condition. And then there is a small but very important change here to the config, to the OS Heat Cloud config, and that's this thing, okay? So what such a wait condition handle actually provides is basically a magic URL, a URL that is the endpoint of our Heat API plus a few magic parameters that basically tells Heat, okay, this specific resource, you now need to update its completion counter. And that wait condition handle object has an attribute called curl CLI, which is literally a curl command. So it's curl, then a few options, and then that magic URL. And you can use this from run command. Run command, recall, is the set of scripts that are being run at the very end of the creation or the update process or whatever. And this is how you can tell the entire stack, okay, we're done here. And this is extremely useful because you can't only use it for telling the stack, okay, we're done with the whole thing, but you might be using something like, we're firing up a single VM, which then for some reason is meant to be the proxy server for all others. So we can first fire up that one, and then we tell all the other VMs, okay, now the proxy server is ready, now we can start firing up all the other ones and so forth. It's really, really extremely useful. And again, we can do that with a stack update command. Okay, so we're going to do the update again. And of course, you know, the packages parameter, we can, whoops, what happened here? The packages parameter we can, of course, leave off again. And seem to be dealing with a flaky network here, so let's see. Oh, what was that? Okay, now it's back. And now it's gone again. Okay, it's like awfully flaky right now. Now it's back, apparently. Okay, we're going to do OpenStack stack update. We can just use all of the existing parameters, right? So it's still going to install Emacs, and it's still going to install Causse. And now we're going to use not the intermediate, but the advanced template. Again, an update in place. Okay. And now I'm going to do one other thing, which is I'm also going to do, I'm going to do a watch OpenStack stack event, come on, event list of my stack. Okay. OpenStack stack event list simply outputs all of the events that happen in this stack. So as we keep going here, some of these things are going to change. Okay, so that's my stack update that has started. And then here we go. All right, so that's my create complete that you can see there at the bottom. Okay, so our terminal resize here was really, really weird. Okay, so let's do this. I'm just going to give you this thing here. There we go. OpenStack stack event list. And there goes the network again. Okay, here we go. So that's like super weird. This is just super slow here. Okay, anyway, I'm just going to walk you through sort of what's happening there. You're going to see that you're going to get these handles created, and only when this handle has actually been fired. What the hell? This is amazing. What is that? Let's try this again. All right, so this still says delete complete for the old VM. Okay, so as you can see here, the VM is actually being replaced. So this is the deletion. This is the creation of the new one. And if at some point this terminal updates again, then we're going to see that the last two things is actually the firing of the wait condition handle, and only then does it go to update complete, right? And so now I can go back to this thing. Again, there's my 72. Again, it complains about the host key having changed because this thing, of course, has been replaced. And there we go. We're right back in. Now with a decent wait condition. And then what happens if you start Emacs no X under Causse? Anyway. So there's a little cow that says hello. All right? Okay. So with the funny issues here that I'm having with the last bit of the slides, I usually have a thing up here that links you to the original slides here. I can, however, just do No, I can just give you another window here, and that is. Oh, of course, and now this bite, here I'm being bitten by a flaky network again. So my slides are up at FG Haas github.io slash OpenStack Israel 2017 dash heat, because I have another talk in just a little bit on Ceph. So that's OpenStack Israel 2017 Ceph. But here, this is sort of the official location. It's very tiny up here. That's fghaas.github.io slash OpenStack 2017 heat. And if you have trouble reading this, then by all means grab me afterward, and I'll be more than happy to share this with you. Okay? So with that, I do apologize for the flaky network issues here. For those of you that actually got themselves virtual machines fired up, okay, and experimenting on this stuff, I'm going to leave these up for the rest of the day. So if you want to like hack on that a little bit throughout the rest of the conference, or maybe tonight, or whichever, those are going to be up. And with that, I'm wrapping up here. I have about 5 minutes for more questions, and then at 3:45 we have the next talk here. So please, grill me. Go ahead. Yes, sir. In which cases do I recommend to use Ansible, and in which cases do I recommend to use heat? My answer is yes. Generally speaking, and I did, as it happens, I did a whole talk about this at the OpenStack Summit in Barcelona last year. You actually have a number of ways that you can orchestrate virtual environments in OpenStack. One is heat. Another is Ansible, another is Juju, another is Cloudify. So there's a bunch of things that you can use there. My general advice is use them and don't not use them. Which of those are more suitable for your specific use case? Depend on your specific use case. There are certain things that I very much like about being able to do in heat that is not possible in any of the other orchestration engines. For example, what I can do with the stack is I can not only create and update it, as I've shown you here, but I can also suspend an entire stack and then bring it back up with a resume. In fact, that is exactly how we maintain these virtual machines for you in our Hostexo Academy training environment. So what's being spun up if you click on a lab is a heat stack. It comes up, and when you're idle for something like 10 minutes, they auto-suspend. And if you come back 2 weeks later, then you get dropped right back into your session where you were. That is something that you can't do with Ansible. It's something that you can't do with Juju. For that matter, it's not even something that you can do with CloudFormation or with GCP Deployment Manager, because none of those have that feature. Another thing that's very neat and handy in Heat is the ability to snapshot and roll back an entire stack. So you can say at some point, okay, like I want to preserve this state of the stack, and I can run a snapshot command on the entire stack. Everything in there will get snapshotted, that is volumes, that's VMs, and so forth, and you then have the ability or the option to roll back to that snapshot state. That, again, is something that I find really, really helpful and useful. So, but it's really two different ways of looking at things. In Heat, you fire up a stack, the stack is your unit, and that unit you can then modify, whereas in Ansible, for example, you run a playbook, and if you want to change the environment, you just make some changes to your playbooks or to your playbook configuration, and then you rerun the playbook. It's just a different way of looking at things. And you can even combine the two, right? You could, for example, you could fire up your VMs and do just sort of a general scaffolding with Heat, and then you could run Ansible over those. Or you can even have your VMs come up and then run Ansible in pull mode, if that's what you want to do. So there's really a lot of ways of doing that, and there's no one right and no one wrong way of doing it. It just so happens that for some use cases, for example, the Heat functionality could be completely indispensable, which is the case, for example, for the training classes and the interactive lab environments that we provide here, right? We absolutely need functionality that is literally only in Heat. It's not in any other cloud orchestration method on OpenStack or any other cloud platform. So sorry to not be able to give a black and white answer here. Okay, if it's good anyway, then great. Okay, more questions, folks? All right, cool. So, I'm actually not even sure. Do we go to a coffee break now? Or are we already over the coffee break and did I deprive you of your coffee, in which case I'm really, really sorry. So let's see. Where are we? Yeah, so rush out, people, and get yourself some coffee because the coffee break ends shortly, and I will be in the track 1 room at 4 talking about Ceph, the good, the bad, and the ugly with Dorit Wasserman.